Hello guys. Uh, this is a problem that is very similar to other problems that we have been working with. Um, let's see what is this about. It says the members of a trust are pinned. Of course, they should be pinned because it's a trust. Adjoint O. Determine the magnitudes of F1 and F2 for equilibrium. And this angle here is 60 degrees. So the key word here is equilibrium. And we are also at a point, meaning a particle. If we are working in a particle equilibrium, a particle can move only let me not it's not that it can move only. If you want to hold a particle in place, you need two forces, two non-collinear forces holding that particle. That means that we're going to have two equations that we can use. Summation of forces in any two directions. For our purposes, it's easier to do summation of forces in x and summation of forces in y. And for equilibrium, meaning there's not going to be any unbalanced force, hence statics, and that has to happen. So if we're going to do that, we know this force, but we have these two unknowns. So we can establish a system of two equations with two unknowns. How do we establish this system of equations? Well, we do summation of forces in x, has to be 0. And when we do summation of forces in x, let's see what we have. This force of 5 kilonewton has this x component right there, and that's going to be 5 cosine 30 negative, because this is positive to the right in this case, so negative 5 cosine 30. This other force has this component, and remember this little triangle here is telling you basically use the parallel component, parallel side, divided by the hypotenuse, so 4/5, and multiply by the magnitude of the force times 7, and it's going to be also negative because it's going in this direction. Now in the other direction, if this is in the other side, if this is 70, this is 20, because they are complementary angles. So the x component coming from F2 will be F2 cosine 20 positive, and for F1 that will be the x component of F1, that is F1 cosine 60 because it's adjacent once again, plus F1 cosine 60 degrees, and that has to be 0. Now we can just work with uh, this system, and we can say F1 cosine 60, so that means 0.5 F1 plus F2 cosine 30, cosine 20, I'm sorry, cosine 20, cosine 20 is 0.9397 F2, and then we have these other two terms that are negative. I'm going to pass them to the other side, but I'm going to combine them first here. So that will be 5 cosine 30 plus 4/5 of 7, and that will be 9.93, and these will define our equation number 1. Now we do the same thing for summation of forces in y equals 0, and then we are dealing with these components here. This component for that force will be 5 sine 30, because now it's opposite to the angle. 5 sine 30 positive because it points up. Now we have this other component here, and that will be, you see these and these are parallel, so that will be 3/5 times 7, but it's pointing downwards, so that will be negative. Not because it's downward, it's because it's opposite to this one, which in this case is downwards. Now the other component for F2 will be this one, and that will be F2 sine 20, once again, because it's opposite to the 20, plus F2 sine 20. And then this other component for F1 is also sine of 60 because it's opposite, F1 sine 60, but it's negative because it's pointing in the negative direction, equals 0. Now we are going to get another equation here. So we're going to have F1 sine, I'm going to pass these two to the other side. So I'm going to have F1 sine 60, that will be positive 0.866 F1. This, if I pass it to the other side, will be negative minus 3/5 sine 20. That will be 0.342 F2. And these two, they're gonna remain, so it's not gonna change the sign. 5 sine 30 minus 3/5 times 7. That will be negative 1.7. And that will be our equation number 2. Now we can solve this system in any way that you want to. I know this calculator solved the system, and I have a small video saying that. Let me see if I remember how to, because I never do that. You click System Solver here, and now you go linear equations 2 by 2, which is 1, and this is basically what you do. What is the coefficient here for the first variable? 0.5, and for the second is 0.9397. 0.9397. Okay. And the independent term here on the other side is 9.93. And then we go to the next one, 0.866 minus 0.342 equals negative 1.7. And this is the system. Check it one more time. And those will be the values for our equations. Where the first one, remember, we call it F1. So F1 will be equal to 1.83, and F2 equals 9.59, 9.60, and the units are kilonewton for each one of them. You see, the only difference between these problems and the problems in the previous chapter are these words. Previously, we were just doing summation of forces in X, summation of forces in Y, and calculating a resultant force. Now we are doing summation of forces in X and Y equals 0 for the system to be in equilibrium. Keep watching, guys. See you next.